Let's start with relative dating. Charles Lyell wrote one of the first textbooks on geology in the early 1800s, and he was building on what he learned from Steno from the 1700s, just establishing more of the relative dating techniques with earth materials and events in geology. So we'll go over the different principles that Charles Lyell kind of started with and that we've developed over the last 200 years or so. So the first one is uniformitarianism. In this image on the left side, you have present day mud cracks. So clay in sediment, when it gets wet, it expands, and when it dries out, it contracts. And so that is an image of clay, rich mud that was wet, dried out, shrunk, and cracked. On the right side is ancient mud cracks. So in the rock record, here are some mud cracks. You still see those same shapes. And so we see it in the rocks, we see it in the present. The present is the key of the past. In uniformitarianism, we can apply it also to igneous rocks. On the left is present day volcanism with lava flows, and on the right, there's layer after layer of lava flows. Again, the present, lava flowing out of a mountain, is the key to the past. These layers that represent time at the bottom is the oldest, the top is the youngest, and lava flow after lava flow stacking up in that sequence. Sediments were deposited horizontally. The exception that we have seen to this is cross-bedded sandstones, where you're preserving just the front side of a dune or a ripple. But in general, sediments are deposited because of gravity that just falls straight down. So you get layer upon layer of sediments, flat lying horizontal to the Earth's surface. So on the right, there's a sketch of what a geologist might see, and in there are some cross beds. So these are the ones that are not horizontal. Okay. Superposition. This is a relative dating technique, pretty straightforward, that the unit that's on the bottom in a big sequence or any sequence of sedimentary rocks, the oldest rock is going to be on the bottom. So if we were filling up like this beaker here, we pour in time 1, some sand, time 2, some red sand, time 3, some darker sand. The oldest one is going to be on the bottom. Strata is just another word for the layer. Lateral continuity. Now, that's a good one. Layers are deposited in big basins, and they're going to be continuous for the size of that basin in most cases. So there's laterally continuous till maybe there's a deposition grain size change, but they go for a long ways. As the sediments pile up over time, they turn into rocks, and you have sedimentary rocks. The sea goes away, you're left with these long, big flat areas of beds of sedimentary rock, and then those get dissected by rivers. Here in this image is today. Here's a river in the bottom. It's going to cut through those layers, kind of exposing the stream channel sediments. And those rocks are the ones that were in the time of deposition in the basin, laterally continuous. So over space, we can kind of connect over those different beds. This image up here is showing similar things. The laterally continuous white beds here at the top of that plateau connect over to these in the background, connect over to these sediments in the foreground, and then the red layers just below that connect over to the red layers off in the distance. Okay. Cross-cutting relationships. If a geologic event or rock type cuts across another rock, the rock that is cut across had to already be there. So in this sequence, the white ones, blue ones, yellow ones had to already be there for the intrusive igneous rock, the dike, to shoot up through them. So the dike is younger than the yellow, blue, and white rocks. And then younger than the dike is that red layer, because the dike is not cutting across that red layer. So the sequence here would be the white rocks were deposited, the blue rocks, the yellow rocks. The dike cut through those, and then the red rocks were deposited on top of the whole sequence. Cross-cutting relationships. Here is Pluton. So a dike is just a skinny little intrusion, but in this is a big Pluton, and it's shot up into that same sequence of rocks, and it has cooked the edges. So we have the baked contact here is like slightly metamorphosed, maybe some contact metamorphism in those rocks. So the country rock is older, it had to be there first. Then the intrusion came in, it's younger. Then at the top it was eroded a bit. All right, so when intrusions come in, or it can even be with a river flowing through, it can rip up pieces of the pre-existing rock. So this is called the principle of inclusions, where there's a rock fragment within another rock. If that rock fragment is in another rock, that rock fragment had to be older than the new rock. So in the case of the flow here, you've got this yellow rock has pieces of the blue rock in it. Over here you have a sill that's been intruded into the country rock, and it's ripped up pieces of the wall of the sill, those yellow ones, and those have to be older than the sill. Okay, so what we usually have is something like this, like a big, crazy, complicated sequence. And we've got to figure out what happened first, second, third, and so on. So in this example, we have a fault. There is a dike and a sill and a Pluton. There's sedimentary rocks and igneous rocks. We have, so let's break down the sequence here. And we have the land surface. So what happened first was the limestone had to be deposited. So see number 1 is limestone down here in the corner. And then the sequence goes, it's limestone, and then they're calling that siltstone, shale. Shale, and then a sandstone, and a shale, and then a sill, igneous, and then a sandstone, and then another shale up here at the top. So 1, 2, 3, 4, 5, 6. And there's another sandstone above that was faulted in place. That would be 7. And then, are there other numbers? Sorry. Nope. Then the whole thing had to be intruded by the Pluton. And then the Pluton was cut by the fault. So the Pluton intruded, picked up pieces of number 5. Then the Pluton intruded, and then the whole thing was cut by the fault after the Pluton intruded. And then after the fault, there was intrusion of the dike, right? Had to happen last. And the very last thing is the creation of this surface here. So this walks through those steps. So take some time. Go back over to the PowerPoint presentation and work through those sequence of steps. The sedimentation, the sill came through, the Pluton cutting by the fault, and then the dike cutting through. So go back through that on your own.